us understand the meaning of electric flux. Here we have an electric field pointing in this direction, and here we have also shown an area element. This area element may be a part of a real surface or it may be a hypothetical surface in space. This area element ds is present, and the area vector a vector is pointing normal to the area element. Let's understand this. So the area vector a is pointing normal to the area element. So here we are treating area as a vector quantity. We are to figure out how much electric field effectively quote unquote passes via this area element. Now naturally what we can write down is the electric field that goes through the area. So let us say this is the electric field. The electric field will effectively have two components. One component which will be along the area vector direction, that is perpendicular to the given area, and one component will be parallel to the area. So the component that is parallel to the area, we can conceptually think does not pass through the area because it kind of moves tangentially to the area, and hence it does not pass through the area, and thus the component that passes through the area is actually now, since e cos theta is this perpendicular component, we as physicists choose to define a quantity called as the electric flux. The electric flux phi e is given as E dot dA over the small area element dA. So we can write this down as the small flux d phi e. Now this E dot dA will naturally give us E dA cos theta, and hence the E cos theta component, that is the component of the electric field along the area vector, is automatically taken care of, and thus we denote and write down what the electric flux happens to be. It is E dot dA. Now if we are to find out the electric flux over the entire area ds, so this is a small area that we have drawn over here, which is the area dA. This is the small area dA. But if we integrate, we'll get the entire area of the surface ds. So the entire flux phi e will be equal to integration of d phi e, which will be equal to integration of E dot dA. And since this is over a surface, sometimes this integral is written down as double integral, and if it is an enclosed surface, we put this circle on top of the two integrals. As of now I am not putting this circle down because this surface is not necessarily an enclosed surface for us while we define the electric flux, and hence this is the net electric flux. So this also comes out to be E dA cos of theta. Let us understand that this value cos of theta will be different at different points on the area, and hence this particular value of cos of theta will have to be taken as per the geometry of the situation and the direction of the electric field, and this is the definition of what we can call as the electric flux.